Welcome to this presentation on the Electrical Power Teaching Laboratory at Loughborough University. This is used for undergraduate teaching years 1 to 3 for the bachelor's and a 4th year for the master's. This is all relatively new equipment which was installed about 2 years ago. In the first year, students will learn about three-phase circuits. So these are primarily used for transmitting power over long distances. For example, wind turbines in the north of the UK, in Scotland, down into the load centres in the south. And you can see here the transmission towers on the left consists of 2 three-phase conductors, and we have a smaller overhead line across a farmer's field in a rural area, again with 3 conductors, so 3-phase. So a characteristic of transmission of electrical power is that it needs to be done at very high voltage in order to do the process efficiently. So we need to step the voltage up at the generator, for example the power station, using a transformer, and then we step the voltage back down again at the load, again using a transformer. So here we see one of the feedback experimental rigs, and we have some transformers there for the students to carry out experiments on, and a power analyzer for carrying out measurements. So here this is a very sophisticated equipment that precisely measures voltages, currents, and also power, complex power, and power factor. Here we've got a close-up of the transformer, and we can see that there's 2 transformers here. The one on the left with the cables connected is a single-phase transformer. So this would be used, for example, in a house to power a fridge or a washing machine. And on the right we can see a 3-phase transformer, so we've got 3 circuits on the input and 3 circuits on the output. And we use the power analyzer to measure, again, voltages and currents in the circuit. We now have 10 of these experimental rigs in the laboratory, which means we have 2 students at each rig, giving a total of 20 students in the room. So this allows us to teach a larger cohort of students. So in the past, first years wouldn't have come into the laboratory because there were so many of them, but now with the increased number of rigs we can offer these types of experiments to the first years as well as second and third and 4th years. In the second year, students will be introduced to electrical machines. So here we have 2 types of motor. On the right is an induction motor, which is the workhorse of industry. Almost 60% of generated electrical power goes through one of these motors. They're used for fans, pumps, conveyor belts, crushers, all sorts of industrial processes. On the left we have a high performance servo motor, so this would be used, for example, in very precise positioning applications such as a robot. And here we can see a motor test rig that we've developed for the laboratory. On the right you can see an induction motor connected via a belt to a servo motor. The servo motor is actually driven by an industrial drive, so this is a Siemens power electronic drive, and controlled through a HMI, a human machine interface. So this is a touchscreen device and allows the students to see measurements of speed and torque, and also to interact by setting speeds and different speed profiles, for example sinusoids, triangles, or square waves. So here we have the test rig running, and it's cycling using a sinusoidal speed profile, and you can see the speed meter on the HMI, and you can just about make out the torque meter as well. When students go into the 3rd year, then they look at more advanced topics, for example power electronics and motor drives. So here we have an experimental rig that we've just developed. This is a DC to DC converter. So we have a 20 volt input, and the DC to DC converter acts like a transformer and steps the voltage down to 5 volts. All the control is done via a small Arduino microprocessor that a lot of students are already familiar with before they even arrive at the university. So they can play around with the coding of the Arduino and change the characteristics of the power supply. So careers in the power industry are very good at the moment. There is a lot of call for power engineers. A lot of this is being driven by new green technology, so PV on homes, wind turbines, electric vehicles, for example the Tesla, and also, for example, on aircraft, where the pneumatic and hydraulic systems are being replaced by an electrical system. This saves weight and fuel for the aircraft. Finally, Loughborough is part of the IET Power Academy, so that is a scheme that's run by the IET, includes a small number of universities in the UK and industrial partners. So a student will go through a competitive process and be taken on by an industrial partner. They will then be offered 8 weeks work experience, a salaried placement year, and there is also an attractive bursary and a small amount of money for books. Here we show some of the industrial partners, so well-known companies such as National Grid, Rolls-Royce and Network Rail. Thank you very much for listening to my presentation.